Hello everyone and welcome to this webinar about new indexing. This is the same talk basically that I gave at the Tech Conference, Dynamic Web Tech Conference 2015 on the 27th of February. Who am I? My name is Jeppe and I'm a senior developer at Dynamic Web, and I was one of the principal developers of this new searching API, and I'll be taking you through a more thorough overview of what we talked about in last week's webinar, which is basically how do we work with searching and indexing in Dynamic Web in the new way. Today's session will build upon what we already know. So basically it requires you to have either tried it, attended the tech conference, or viewed the webinar from last week, which is available here. So if we go to the Engage site, then you can find it here under Training, Certification, Media Library, and all the way here in almost at the bottom under the Platform section, you'll find Search and you will find. This basically provides the base knowledge that is required for this session. Okay, so what we'll be going through today? Well, we'll be going through a lot of code, and then we'll be seeing how to use the SQL index builder and how to create our own builders and schema extenders. And then we'll use one specific example where we build a user's index. And if there's time towards the end, then we'll take a sneak peek at some of the features that are coming in 8.7 for this module. All right. So before we look at the specific implementations of the builders, let's just take a quick look at what they actually do. So in last week's session, I showed you this slide where we talked about what indexes are. And indexes pull data from a data store that is then run through a builder, which then produces the actual physical index. Today we'll be talking a lot about this middle box here called builder. This is the one that actually knows about data and how to manipulate it. Okay, I think this will become clearer once we get into it, but let's actually see it in action. So I'll just switch to my browser here, and I already have a repository set up. This is almost the same thing that we saw last week, but this is more focused on users. We'll be getting back to that in a minute, but I'll start by creating a new repository. Actually, I'll start by switching to English. I am sorry about that. Okay, so I'm logged in as an administrator. Nope. And then I'll create a new repository, and I'll call it users. So now I have my users repository. I'll add an index. All of this should be familiar. This is what we talked about last week. So up until this point, nothing new. And unlike last week, I'll only add one instance because this is not going into production right now. But if you were putting this into production, you'd have two instances, or I think you'd aim at having at least two instances, so you'd have failover. But if you want to learn more about that, I recommend you watch the webinar from last week. This is where we'll differ a little bit from what we did. Instead of using the product index builder, we'll use the SQL index builder. We'll just say users, and we'll say execute. This is base setup. This is the command that the SQL index builder understands. Then I can specify some settings for this builder. So I could say a connection string, if I wanted to, that if I had an external database, something that is not the dynamic web database, I could provide the connection string here, and then I'd be able to connect to that. But since I am using the dynamic web database, then I don't have to provide a connection string. Okay, so now I have to provide a query for what it is that I'm actually that I want to index. And in this case, we actually want users, so I'll just type in select star from access user, and then I need to provide where equal 5. So only want regular users, not all of them. That's just I can do any query here. I could do joins. I could do anything if I wanted to. The only requirement is that I'm able to pass in a query that specifies the count. This is basically so we know if we get all of it, and we can provide information in the UI and that nice progress bar. So in this case, I'll just say it's the same query basically. I'll just add count here. So now I'm using the SQL index builder with a custom query, and then I need to add fields. And since I'm using a custom query, I cannot actually use a schema extender, like, because there is no provided schema extender for the SQL index builder. But I can do regular fields, so I could just say username, and then the source. Because I'm using the SQL index builder, I know that the source will always be the name of the column that I specified in my query. So in this case, it'll be access user name, and I know that's a string. And I could provide a boost value, and I could specify whether I want it stored, analyzed, or indexed. In this case, since the username is a key, I want it to be stored and indexed. So I could do this, and I could add all of the fields that I want. But in this case, I don't really want that many. So I'll just add this one field, and then I'll build that. So now the SQL index builder is querying, or rather it should be querying the database and providing a list of users. So now you can see that the process here, I have 150,005 users in my database, and it's now built an index containing the username for each of them. But the SQL index builder runs into issues where you have data that is not readily indexable. So for instance, the users table has a relation between which groups a user is part of, and that string is serialized into one field. So it's an @ sign, then an ID, then an @ sign. That's the serialized string, and then you can have multiple of those in a row. So that's actually not something that I can easily handle just by specifying a query. So to that end, when I have stuff that needs to be manipulated in a different way than just pulling data and storing it in an index, but something that I actually want to do something with, then I can create my own builder. So how do I create a builder? Well, I inherit from, or rather I implement this interface called the iIndex builder. So now I have a public class that I called user index builder, and it inherits from the iIndex builder. The interface says that I need to implement a lot of properties, and most of these you just need to implement as a get set, because these are information that is set outside of the builder, and it's information that the builder needs in order to work in most cases. Then there's one property that we need to give special attention, and that's the one called supported actions. That's a read-only property where you need to return an IEnumerable of string, and the strings that it returns, in this case full, that's actually the builder actions. So you remember we talked about here there are builder actions. So the SQL index builder knows that there's one called execute. Here I can specify full. So I as a builder, I now say I know what full is, and I can react when someone specifies a build using the full action. I could add more to this. I could say partial, or I could say only on Wednesdays, or something like that if I wanted to change the behavior inside of my builder. So the supported actions is the only one that is really required. Okay, so I also need to implement the method called build, where I get an iIndex writer and I get a tracker. I'll get back to the use of both of these in just a second, but let's see what my implementation is like here. I basically want to build an index of users where I also want to add their user IDs, or rather their group IDs, so I know which groups that they're part of, but I don't want that at serialized string. I want it as a proper integer array. Okay, so where do I build? I start by opening the writer. And the writer, the iIndex writer, is the one that handles pushing data into the physical index, or if it's a Solar instance, to that server. So I need to specify open, and then I need to specify whether or not I'm appending to an index or I'm creating a new one. So open for append I specify as false, because I want to create a new index. Then I check the task manager's context to see if the database connection string is provided. And if it is, then I'll use it. If it's not, then I can't really do anything. That's just my implementation. You could do anything. You could specify a connection string in the settings. Let's see if I can find those here. So it's just an iDictionary of string, comma string. You can specify it there if you wanted to do it in the configuration file instead of using the dynamic web connection string. But I'm going to use the connection string. And then I'm opening it, and then I'm creating a command to get the query. And here you can see I call into the tracker. The tracker is the one that's used to collect status about what's going on. So I could write information about what I'm currently doing. So in this case, I'm getting count. I can also do it to increment count, and I can set the total count, which is actually what we want here. So in this case, I'm doing a command where I say, give me all of the access users where the type is 5, the same thing as we did before. And then I'll just convert that result into an integer and throw it into the status parameter of the tracker and set the total count to that value. So now I need to handle the actual users. So I still have my command text here. In this case, I'm not doing the star because I only want these 6 fields. But I'm creating a command. This is basic database connection, and then I'm looping through a reader and saying handling users. And for each read, I'm going to do something with that data. So I'm basically doing the looping over the fields inside of the reader, and I'm pulling out the name of the column and the value of that column. And then I'm saying, okay, if the column is access user groups, then I need to do something specific. If it's not, then I'll just add it to my index document. The index document is the key value collection that the writer uses to write data into the index. So it goes through this key value collection, and then it picks out all the values that you've specified in your schema, and then it takes those values and puts it into the index. And it knows how to handle value. So in this case, value is an object. It could be a string, it could be an integer, it could be a double, it could be a long, anything that comes from the database or anything that I create as the builder, then I could just pass it in. It accepts a string comma object. Okay, so for all of my columns that are not the access user groups, then I'll just add the value to the document. But for access user groups, I want to do something a little bit different. As I told you before, the string is a strange concatenation, so I need to split it according to the @ sign right here. So I'll just do that, and I'll trim all of the extra @ signs. I know that the @ sign is the delimiter, so therefore I know it's either at the beginning or the end, so I can just trim that. I'll loop through all of my IDs that I get from that, and then I'll pass that as an integer, and then I'll return that as a list. So my group ID list in this case would be an IEnumerable of integer, or IList of integer, sorry. I can just add that to the document in the same way that I did all the other ones. So as a document.add groups, and then my list of int. And that's all I need to do. Then I add the document to the writer. Basically tell the writer, I'm now finished filling this document, you can put it into the index. And then when I've done that, I'll tell the tracker that I've done one more iteration. So it increments the counter so we know how many we've handled. This is what provides the progress bar in conjunction with the total count. And that's basically it. That's all I need to do to pull users from my database, handle all values except the group in a simple way, and for groups do something different. This is a very simple example, but you might imagine that you could do very large and very complex manipulation operations inside of the builder, and that's basically what the builder is for. So for simple actions where it's just pulling data from the database, you could use the SQL index builder. Once it becomes a little bit more complex than that, then I recommend that you create your own index builder. Okay, so I have an index builder that provides some fields. I need to create a schema extender to make it easy for my users to use this builder. This is what we've done for the e-commerce, the product index builder. And you can also create your own. So what I have here is a user schema extender. And the way I create one of those is I create a class that implements the index schema extender. That has one method that I need to implement, that's the get fields. So in this case, I just create a new field, or rather a new list of field definition base, and I fill it with all the fields that I have. Let's look at one. So in this case, the user ID, I specify the name. This is the nice name that is presented in the user interface. The system name, that's the one that's the name of the field that will be created in the index. And then I have the source. This is which key in the document. So this document right here, the index document, which key inside of that should this field get its values from? And how should I interpret those values? So I provide the type. That's the .NET system type that I provide for whatever type of object exists for that key. I also specified whether it should be stored, indexed, or analyzed. So in this case, it's an integer key, so I say it should be stored and it should be indexed, but I don't want it to be analyzed. So I create a number of these field definitions. And you might notice that I've created a field definition, but my list consists of field definition base. The reason for this is that the field definition base is the base type for all fields, but we have multiple types of fields. We have the summary field, and we have the extender field, which is actually, this is a field in and of itself, but you could create one of those, but I wouldn't recommend it. And then we have the grouping fields that you can also create from code. So that's why I create a list of field definition base, and I create objects that are field definition. Field definition is just a basic definition for a field. All right, let's look at the other fields that I have. So I have username, same story, and email allowed, which is a Boolean value, so it's specified as Boolean. And then the last one is the groups. So we saw that the index builder adds to the document a key called groups, to which it adds the list of integers that are the group IDs. So I know that, and also I specify name, and not least of all the source, in this case groups. That's the one that is this key right here. And I specify that as an integer 32. So that's basically an integer array. I store it and index it, and that's basically it. So that's how you'd create one of these. So let's see what that looks like when that's implemented. So I have my index here. I'll just remove all of these, and then I'll add a new build definition. So I'm using my user index builder. That's the one that we saw the code for just a minute ago. I'll just call it full build as well, or rather I'll call it full build. And then I specify full. So you remember that's the list of supported actions. So that's where the full comes into play. That's right here. And I click OK. So now I have my build definition that's using my custom builder. Then I'll add my field and I'll say it's a schema extender. And I'll select the user schema extender. I'll click OK. And I'll save that. And we can just expand it and see which fields it knows about. So the ID, name, or username, name, email, can send email, and groups. So that's what I specified in my schema extender. I just collapse that again, and I'll press the build button. So now it's using my custom builder, pulling data from the database, manipulating it, and creating the schema inside of the index based on my schema extender. So now I've actually built my index of 150,005, and now this index is actually ready to use. So I could add a query. It says all users, and that uses my index. I'll just click save and close. So now I have an index and a query. But how do I actually use these queries inside of the dynamic web? Because this is not a product index, so I don't have a product catalog. In 8.6.1.13 that we just released yesterday, so that was on the 30th of June 2015, there's actually a sort of a hacky way that you can get that to work. You need to create a reference to a specific module that exists inside of a dynamic web. So I think I have it here somewhere. Let me just go to the next page. It's called the query sandbox. I know I have it, so let me just show you what it looks like. I'll provide some information about how to actually get it into an 8.6.1 solution, but it's not an official module, so it's not supported yet. Wouldn't recommend you going live using this, but it is implemented in 8.7, and when we get to the sneak peek of 8.7, I'll show you what it looks like there. Okay, so this is the basic interface for the query sandbox in 8.6.1. So I'll specify a query and a facet. In this case, I don't have any facets, so I won't use that. And then I have the template that I'm using. This is a Razor template. This module does require a Razor template in order to function to its full potential, because since we don't know what type of object we're rendering, then we just pass that object along to the template. So it's up to you in your Razor template to actually manipulate the object and render it to the user. So in this case, my template is very, very simple. I'll just show it to you here. So just get the query result. This is a value that is passed to the template, and I know that it's an iQuery result. So I say if I have one of those, then I print out count, total count, and then I convert my result to a JSON object that I'll render to the user. This is not something that I'd use in production. This is something that I'd use for testing. All right, so now I have this one, and let's just actually look at what that page looks like. So in this case, I'm just doing my query, and it tells me that I have a count of 10. This is because if no count is specified when I do a query, then it'll always use a fallback to 10. It tells me my total count, which matches up with what I saw when the index was built. And then I see all of my elements here. Actually, in this case, I'm using the one that I've already created that has a parameter, so I could specify email equal to JEA534 maybe. So it finds all of my objects. So you can see the querying still works with the parameters that we discussed last week as well. So it still works. It's passing the value into my parameter inside of my query, and my query then reacts to that. So now I've specified JEA534. It tells me there are only 111 users in my database where the email has JEA534 in some way in front of it. So that's how you'd set up and work with this inside 8.6.1. But now let's switch to the 8.7, where things become a little more interesting. I'll start by showing off some of the more quality of life related things that we've added. So first of all, you might notice that the order here is a bit different. Actually, I might just log out for just 1 second and then log in as an administrator instead, so you don't see all those asterisks. There we go. So I'll just go back to the management center, my repository, and in this case, my products. So like I was saying, you can see that I have a new order here. So it's actually ordered in the way that the structure works. So if you remember from last week, we had the hierarchy of objects. So you have the repository at the bottom, and then above that you have the index. And the index is the foundation for all queries, and queries are foundations for all facet groups. So that's basically the order in which you see it here. So you have indexes at the top, then you have queries, then you have facets, and then at the bottom you'd find the tasks. I'll get back to those in just a second. But if we look at the index, so you still have my regular user interface, but I also have a new thing called field types. Field types I can use if I want to create a special type of field that uses a different analyzer or has some sort of static setup. So I want a specific type that uses one analyzer and has a boost value as of a specific system type as well. So I could add one of those. Let me just show you what that looks like. So I'll create one called maybe white space custom without boost. I'll specify that that's a string, and then I can add analyzers for each of the instance types that I have. So out of the box, Dynamic Web comes with the Lucene index provider. So if you've created your own, let's say you've created a Solar, or let's say we create a Solar instance at some point, and you create one that's in so my B one up here might be a Solar and my A is a Lucene. Then those would appear here in this drop down, so I can select which analyzer do I want to use if I'm using the Lucene provider, and which analyzer do I want to use if I'm using the Solar provider. So I'll select the Lucene one, and then I'll select which provider I'll use. The system will automatically discover which analyzers are available. So in this case, I'll just select my white space analyzer and I'll click OK. So now I have a new field type that's a custom white space without boost. So if I create a new field, it will appear here under types. So you can see I have the system types at the top, and then I have my custom field types at the bottom. All right, so that's one quality of life improvement that we've added. I also talked about tasks just a minute ago. So let me just add a new task. So I'll say scheduled Saturday build. So I might say that this is a build that runs every Saturday. So I can specify a start time and an end time if I want to do that. If I say never, then basically it's always valid. I can specify a repeat interval for how often I want this to run. This is in minutes. Then I specify which task provider I want to use. I specify which index I want to build and which build I want to execute. So if I do this, then this build will automatically run based on my setup, and I can build my indexes based on a schedule. You can always, this is something that was added in 8.6.1 as well. When you finish an import job, then you can also specify that you want a specific build on a specific index to be executed. That's also a very handy thing. All right, so that's some of the quality of life improvements that we've added to this. One thing I do want to show you, actually, this is something that I like very much. It's actually when I have a build that's using a specific builder, I no longer have to specify the type, or rather the source, manually. I get a nice drop down with all the fields that the builder exposes. So I no longer have to guess. It's just here, and I can pick and choose whichever one I want. So I could use the ID, for instance. All right. So that's not all that's changed. We've also changed how the product catalog works with regard to indexes. So if I just look at my setup here, you can see I've selected that it uses the index. So now I'm actually, instead of selecting a facet group that I'm doing currently on 8.6.1, I'm selecting a query, and then I can append all the facets that are using this query. So if I had multiple facet groups using this query, I could add those here, and I can rearrange the order. So that makes it a lot easier for me as the implementer of the index and the facet groups to actually segment a bit more. So I can say I have something that's a standard product facet, and then maybe I want to have different facet groups available for different types of products. Or different categories, or whatever type of filter I want to use, and I can specify which ones I use inside of my template. I have full control over that. So that's very nice. And the other thing that we've added the query publisher as an actual module. So you can see in this case it actually uses a fairly similar setup to the product catalog, where I specify a query, and then I specify all the facets that I want, and then I can say I want a set of items. How many do I want? So it's no longer hard-coded to 10. It defaults to 10, but I could change it to 100 if I wanted to. Okay, so this is just basic quality of life improvements. Lastly, I want to show you a couple of things that we've added. So let me just go into this repository here. So you can see I have 3 indexes here, one called product with price range. This is the one that we saw in last week's session. Then I have 2 other ones. I have one called content and one called users. And the users one is actually using a builder that we'll be providing in 8.7 that can index users, along with a schema extender for that one. So that's actually something that's built in out of the box. So you can have a user index using basic code. You don't have to create one that I just show you, but in 8.6.1 you do. There's the other one called content, where we also have created a content index provider along with a schema extender, so you can analyze all your paragraphs. One thing to note though, that this is not currently capable of handling items. It can index regular paragraphs and page content, but it cannot handle items. It's something that we're working on, but I'm not sure that we'll be able to finish it for the 8.7 release. But at some point after the 8.7 release, we will be adding item support to the content index builder. And of course, as long as I have an index, I can also create queries that use it. So you can see I can use my user index, and I actually have one here. This is actually using the content. Sorry, I've set it up for something else. I think I've set it up for product, so I could just switch it to users if I wanted to, and click save and reload this page. So now it actually shows me all the users that I have in my solution. I don't have that many, but I do have some, and I could switch to content as well, so I can see what content I have. And now it specifies the content that I have, and you can also see that it knows about paragraph text and stuff like that. This template, you can always change that. This is just the default template that we provide. So this is basically a representation of the key value collection that exists inside the index that is available to view. So it's basically all the stored data that you can see here. All right, I think that's all I wanted to show you today. So where do you get more information about this? This webinar has been recorded, so it'll be available online shortly. Also on the forums, there are quite a few threads already with regard to the index. And also we have the preliminary documentation on how to use this. And you can find that on our developer site under the documentation. I'll just show you how to get there. So when you get to the front page, click documentation. Sorry, you click downloads, and then you click documentation. And then it exists right here under the dynamic web section. It's called indexing draft. And then you can download the PDF from here. So I know that this was a more technical rundown than what we saw last week, but if there are any questions, I'll be happy to answer them here. Let's see if there are any questions that come up. So okay, so we have one here. In previous versions of Dynamic Web, we had search query syntax to query the indexes. How can we now query our indexes through code? Will there be documentation, examples of code for querying indexes? So yes, it definitely you can do that. Let me just shut this this thing down. Let's go back to a Visual Studio. Let me just open up a solution right here. This is basically the code for 8.6.1. The same syntax that we use for creating our expressions, the ones that we've seen here. Let me just show you the expressions so we all know what we're talking about. So on the query here, all these expressions right here, that's basically an object in the same way that you use expression trees inside of .NET Link and dynamic languages. We have one here, so you can do this, and let me just show you what that looks like, so you have maybe an understanding of what is available. Let me open the querying and the expression. So you see here you have a binary expression, constant expressions, group expressions, and all of this where you can specify. So let's do one example. Let's do let's look at the binary, the expression helper. So basically this one will be able to create parameter expressions or macro expressions or field expressions or whatever type you want, and they can be created using the expression class. So you can say I want an expression that is a greater than expression. You can specify what's the field, so the field expression on the left. So in this case, what's the field and what's the source? And you can also specify what's the expression on the right. Is it a constant expression, or is it a macro expression, or a parameter expression? All of these basically inherit from the value expression, and you'll specify that on the right, and then it'll create a binary expression with those two. So you don't actually specify a Lucene querying language or a Solar querying language. We use our abstraction on top of that, and the reason we do that is because the querying language is not the same across all of the different providers that we can use. So we have to have an abstraction that's used for that. Though the Lucene index provider, let me just show you that really quickly. So we have it here. That's actually capable of passing this expression. So it'll do it here. So let's say if it's a group expression, then it'll do a loop, and then if it's a binary expression, it'll find the field, and it'll find the value, and then it'll do a lot of stuff based on the operator. So that's what you do. It's not actually specifying a query like you do if you're using Luke or Luke.NET, depending on which version you like. You have to use the abstract. The abstraction that we provide in order to do that. I hope that answers your question. So let's see if there are any other questions. Not of using code, no, not currently. We are working on documentation for that. The preliminary doc that we provided is not available. Well, the preliminary doc is available, but it doesn't talk about using code. It's exactly the one that you link right there. We will be providing something similar for the new indexing, but it's not done yet. If you have any specific questions, please ask them on the forums, and I'll get to them and answer specific questions on there. And then once we've created the documentation, it'll also be available, and we'll link to that heavily. All right. So fuzzy search was not implemented in previous versions for search query syntax based on Lucene. How can we use fuzzy search? Well, you can't really at the moment, because we actually do the conversion to the actual syntax. So at the moment you can't, but it's something, if it's something that you want, if you want to be able to handle specific types of searches, we might consider adding it to our abstraction, but currently you can't. So will we have online source code from the webinar? Yeah, I'll add those. I don't know where. I think I'll add them either on the GitHub for the tech conference, or on our developer site. Keep an eye out for a sticky post in the developer forum under development, and I'll add a sticky post there with a link to where you can find the code. Okay. So any other question? Well, thank you, Amir. So it seems that we've run out of questions for this seminar. If anything pops up, if you think of anything or something that you'd like to know more about, drop a question on the forum, and I'll get to it. I'll have a look at it when I can. Other than that, thanks for showing up, and thanks for watching, and I'll see you next time.